A very good afternoon, ladies and gentlemen. Meshmix Media, in collaboration with Laghu, Udyog, Bharati, and IMS Foundation, has come up with this knowledge forum where we will be talking on different subjects. 13 episodes have been planned. First was on drone. The second was in Vision 2040. Now we are on the third. Today's topic of discussion is smart factories and lean manufacturing in aerospace. We'll talk about challenges and opportunities, and we will try to dive deep in the subject. We have got 1.5 hours with us, and today, I'm happy to say we have got a great panel speakers. We have with us Mr. Himanshu Jadhav, Director and CEO, Jendamark India Private Limited. We have with us Mr. Viswajit Bhattacharya, lead client partner and automotive industry leader, IBM Consulting, India and South Asia. Mr. Federico Poli, Aerospace and Defense Group Industry Manager, Marposs. Thank you, everyone, and agreeing to speak on the topic. So we want to start the discussion, to ponder on the topic and bit more about what your company do. We want to start with Himanshu. You.
Hi, good afternoon, everyone. My name is Himanshu, and I'm the CEO and Director for Jendamark. Thank you, Dinesh, for inviting us to this forum and to my co-panelist as well. Welcome to everyone, and welcome to Poli from Italy, I think. So thanks a lot. So about Jendamark, so we are a manufacturing technology company which provides solutions primarily to automotive companies, but we are also significantly present in manufacturing jigs, fixtures, toolings, and MRO facilities for aerospace companies. And for both these companies, we have our head office in South Africa. We are present in India, Germany, and US. We are around 800 employees in the globe right now, providing, like I mentioned, mostly automotive solutions. While we were doing, and which we have been doing for the last 30 years, we actually realized a need for a very on the floor software solution which helps improve efficiencies. And that is how Odin, our software solution, was born. And we have deployed it successfully in 30 plus sites globally, including big OEMs in automotive like Audis and Volkswagens, and right up to tier ones and MSMEs as well. So this is a very interesting topic for me, is because we have access. Like I mentioned, we provide a lot of manufactured toolings to aerospace companies, whether it's Boeing, Pratt and Whitney. So we provide a lot of toolings to them, and we have also seen their manufacturing shop floor. And then we work a significant chunk of our time with automotive companies which have scaled up a lot in terms of automation and now smart manufacturing. So my purpose of being on this panel discussion is to actually show the team and the participants how the solutions on the automotive side vis-a-vis can be directly implemented on the aerospace side as well, which improves, like the theme of the session is productivity, efficiency, saves cost, gets a lot of efficiency in terms of human efficiency into the system, and the dependency which I think India will have, like we had in the EV. When the EV thing grew up, we had a lot of shortage of skills. I believe with the aerospace and defense opening up significantly, there will be the similar issues which were in the EV industry, which was solved with smart manufacturing. So I feel that aerospace stands to gain from this experience of using smart manufacturing solutions, automation solutions, lean practices, which are there since decades now in automotive, implied and applied directly in aerospace industry. So that's why I am here, and I hope to share some slides with the team here to show how this can be implemented.
Thanks, Himanshu. Viswajit, your views on the topic and more about what IBM does in the space.
Thanks, Dinesh. Good afternoon, everyone. I'm Viswajit Bhattacharya, a partner in IBM Consulting. So in IBM, we are, in a single sentence to say, we are partner in clients' transformation journey across the world, including India. And India is one of our key focused market among few others. Now, Dinesh, first of all, thanks for bringing this particular topic, smart factories and lean manufacturing in aerospace. That's very apt for the time, and specifically looking at the markets in Indian market, the way we are focusing on this particular industry and smart factories are going to really augment the whole process. Now, if you look at it globally, this industry leaders, aerospace leaders, are investing heavily in what we call digital agility. What I mean by digital agility is able to respond quickly to the market shift, supply chain disruptions, and evolving customer demands. And if we talk about individually, the geopolitical situation is very volatile, to say the least. And from that standpoint, the shift in market, the shift in terms of the whole demand pattern, it's constantly kind of happening. The supply chain disruptions are the norm, and just leaning on automotive industry. We started with COVID in 2020. Immediately, once the COVID got settled, the semiconductor became the big issue in terms of the managing or their production supply for that. And once they got a bit of stability into the semiconductor, the rare earth issues, which really affecting the EV industry now, especially the motor manufacturing in EV industry. So these kind of disruptions are there and probably going to be there. And similarly, the customer demands are also evolving. And whether if you're talking about the end consumer, and then and that's something which is getting populated down the value chain of the industry. Now, given that all these factors are there and will continue to really be a disturbing force for the industry, it's important that how do we make ourselves agile, and how digital technologies can really help us in that sense. And this particular agility, what we look at essentially is being powered by the smart factories, AI-driven operation, and a data-centric decision-making approach. At IBM, we define smart factories as something which is connected, cognitive, and adaptive production environment. So it integrates various technologies like IoT, digital twin, and various cyber physical system to create a seamless flow of data between man, machine, and the systems and the processes, essentially. So with that, Dinesh, I'll hand it over to you.
So, Poli?
Yeah. So the point that had been already highlighted is statement. So we are seeing a huge increasing for what concerns aerospace activities. This huge demand is something that specifically to the aerospace business had been something that were not present in the past. We are seeing that the huge demand that is happening right now is closely to the automotive demand that had been happening in the last 30 years. Now the electrification and the possible changing of the ICE combustion engine is something that will be defined later on in the upcoming years. But up to now, what we are seeing is that aerospace is specifically requesting a huge increasing of demand. How we could satisfy this kind of needed request that up to now is booming, looks like that is booming. For sure, with processes, with inspection, with solution that could in some cases help to provide, to produce components in a quicker way, and with the same high standard of quality that in aerospace business overall it is mandatory to achieve in the right way. Marposs, according to that, is a let's say solution maker that is in condition to provide different processes that could give value for what concern huge demand of quickly process monitoring, but also quality inspection for components that must be identified and manufactured according to the strict demand of the end users.
So we want to start the discussion with you, Himanshu. at a very basic level, what are the components of smart factories and lean manufacturing? If a SME or MSME want to understand the basic, like a layman, because it's the MSME and deep down, they want to understand, what are the basic, key components, smart factory and lean manufacturing.
So I think, and I'll try to give an analogy to make it easier, because you mentioned that it should be easy to understand. So I don't like to use big jargons in terms of for me, ML, and when people talk about a lot of things, I feel that kind of does not clearly explain what is the step. First of all, I think going towards smart factory is not a step, but it is a series of steps. It's a journey which has to start. It cannot be, okay, let's buy smart factory. I think that's something which everybody has to understand, that you can't buy a smart factory. You have to create a smart factory, and the creation process of smart factory is in steps. It starts, typically in our industry, we explain people that it starts with digitization. So you first start to digitize what you are doing. Second step is digitalization of the processes. And the third step is a digital transformation. And in that process, then you end up with smart factory. So now coming to simple layman's terms, I think in India especially, we have all over the last few years got used to scanning barcodes at any shop as well, right? We are happy to scan a barcode and access and do transactions. For me, that's the easiest entry point to start the digital process or digital journey process. We should, and that's what be the first step is. It's called, end of the day, it's a cultural transformation, right? We can't suddenly say that let's start becoming digital and change everything. So the cultural transformation starts by simple things like let's scan barcodes and read information of either the product, the process on the shop floor, which can be easily accessed, right? So smart starts with simple. It does
Okay.
not start with complicated things, right? So you start a very simple small step. Let's start by scanning barcodes on the shop floor to access information, to access knowledge. Then slowly transit it to accessing process documents, accessing information which will help the operators. Second easy step to start is, we have unfortunately still, and I'm sure in aerospace it's still there, which I've seen myself, is instruction manuals how to assemble component, and how to log what you're doing. So there are thick instruction manuals of how to assemble things. Then there are documents where you are certifying and checking that you have done something. Change that to a digital work instruction. Simple digital work instruction, which allows you to read, see in your local language, and once you are doing the step which is shown to you, acknowledge digitally it's done. So
Okay.
now while you're doing these steps, you're actually collecting data. And like I said, this is the first step of the journey. Then you think of adding certain tools, which could be collaborative robots, which could be tightening tools, which could be camera vision systems, AMRs, as a second step. The problem what we have realized is, and I've got some layers which I can share later as well, whenever we are allowed to share some slides, is what we and my colleagues call is putting a golden hat on a shack. You can't start directly by putting digital ERP, MES solutions when the foundation is still on manufacturing and assembly level. We have to bring the next level of automation and sensors, which is basically the data collecting tools. Then you have to bring in the layer of MES or line operating systems. And on top of that sits the ERP. And I think what is easier said than done is to get into the layer above manufacturing, into the layer of automation and solutions which are actually not smart factory solutions, but which are actually essential to get the data out. Putting tightening tools, putting printers, putting scanners, barcodes, PLC layer. That's the layer which unfortunately is not implemented, and directly a layer of digital solutions is implemented, which doesn't work. Like for example, if I've got Federico, if you don't have a Marposs gauge, you can't get the value. But people want to know the value without a gauge. It doesn't work like that. And that's why I said that the journey of smart factory should start with very simple, basic steps. Scan a barcode. And that's my always comment to everybody: scan a barcode in a shop floor first, and then let's start talking. And then you go towards digitalization, automation, MES, ERP, and then you have a smart factory.
Thanks so much. Vishwajit, hold your thought. Ladies and gentlemen, we have with us Mr. Colonel K.V. Kuber, Indian Army veteran, Director Aerospace and Defense, Ernst Young. It's good to have you, Colonel Kuber. Uh, 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 can you let us know more about what you do into the aerospace and defense, what EY does, and then we can take it.
Yeah, thank you, Dinesh, and very good afternoon to everybody. So, EY is a largest consulting firm in the world, and in India, again, we are the largest. Also, we operate on multiple verticals and horizontals. Everybody understands EY as an audit firm. So, well, I think they started as an audit, and then they do a lot of consultancy. An enormous amount of technical consultancy takes place, and business consultancy, um, uh, regulatory advisory, tax transactions, mergers, acquisitions, doing raising funds for companies, funding propositions. And also, we do a lot of thought leadership in various sectors. And we've got a number of sectors. I mean, almost all sectors that you can think of, from mining, oil and gas to this thing. So what I do as part of the whole, about more than about 1.5 lakh people in India, we are a small team of 5 people who are part of the core aerospace and defense team. And what we do here in the aerospace and defense is we track the sector. We try to understand the sector because it's a very complicated sector. And while everybody thinks defense is all about weapons and maybe ammunition, but then there's a lot more to defense than ammunition and weapons. So it's about technology. It's about adapting technology. It's about getting getting an information superiority. And just as an example, if I were to say, because today, fortunately, we are we've been quoting various other wars, whether it was in Syria or Israel, Hamas, or Russia, Ukraine. But today we have a template in front of us, and the whole world is talking about Operation Sindoor and how India reacted to a particular hostile situation by Pakistan, and how we reacted in a very measured and a mature manner, only to get escalated by Pakistan because they changed the rules of engagement, and they thought that by changing the rules of engagement, India may succumb. In fact, when they changed the rules, we played by those rules, and then the rest is history. So we know today that if Israel and the US took a shot at the nuclear facilities of Iran, they actually copied what we did to Kirana Hills. So when Pakistan changed the rules of engagement, in which, what I mean is, they went and attacked our military systems inside our territory, whereas we were attacking only the terrorist bases. While we took on the terrorist bases in Pakistan without any collateral damage to any civilians in the area, Pakistan changed the rules and they attacked our aircrafts. And therefore, we took very punitive action. So India, by nature, is only on retaliatory mode. We are not the aggressors. So when we change the rules of the game today, we talk about what happened in operations. Why am I even talking about it, and how is it relevant to smart manufacturing? So you see, there are 3 or 4 major aspects that have come about in operations. One is It could be a short and a swift war, unlike the prolonged wars that we are seeing in Ukraine and Gaza. Second is it was a technology-oriented war. Third is it was about strategic systems. Fourth is it was about a very credible defense, air defense. And how do you come about with a very credible air defense? Or how do you come about with a strategic missile system that could go and attack? Or how do you come about with a loitering munition that could go and cause damage to place X, Y, or Z? How can you take out 15 different terrorist bases at different places, at different geographical locations, almost at the same time, and actually prove to the world that you do it? So it all happens only when your industry is able to support you in the time that you want them to support. And here is where I want to bring about as to how the Indian armed forces have been traditionally procuring weapons and how that is changing. So since independence, we had a very poor industrial base, because the British robbed everything and they took everything away. So when they rob you of everything and you are left with nothing in the country, you start from scratch. And when we started from scratch, we had an immediate war in 1948. And I wish we prolonged it a few days, and the POK would never have been POK. It would have been with us. I mean, we would have had the entire Kashmir with us if we didn't go to the UN. That said, we started with the government-owned public sector units, government-owned units. The strategic sector was placed under the government control, and therefore it was a reserved sector. That changed much later. I'm cutting the story short to say that changed much later in 1991 when Mr. Narasimha Rao moved us towards the capitalistic economy, and the private sector was allowed to come in. Now, what happened in this was this. When private sector starts coming in, the global best practices kick in. When private sector starts coming in and also coming in as a competition to the government sector, they bring in a lot of efficiencies and best practices, and one of them was smart manufacturing. Now, there are two things. One, I think we are talking about both smart and lean. Maybe later we can come to that. But the point here is efficiencies were increased. When efficiency increases, the cost of production reduces. When the cost of production reduces to the same cost, you can buy more weapons. And when you buy those weapons from within the country, and when we embarked on this journey of Atmanirbhar Bharat, more money flows into the economy. And as more money flows into the economy, more production takes place. Today, we are already at about 1 lakh and plus crores of defense production from a mere 20 odd thousand about 10 years ago. And we are aspiring to be 1,75,000 crores in about just 1 year or so. And I think we'll achieve it. So what we do is we track the sector. What we do is we keep an eye on various procurements that are taking place. We keep an eye on the industry as to how the industry is progressing. We keep an eye on technologies, how they are emerging. We keep an eye on how collaborations are taking place. We advise the government at times. We advise the state governments at least about 23 state governments we are advising. We are advising the central government, the Ministry of Defense. We advise them on the two defense corridors, how they should come up, what should be the manner in which they should come up, and what type of synergies we can bring into the industry. And then we also advise some companies in terms of market entry. Everybody says defense is so difficult. Can we also do defense? Yeah, of course. Why not? So we tell them as to what are the problems in defense, what are the challenges that they, what are the concerns, what are the regulatory, what is the licensing requirements, what would be the type of ROI they could get on specific disciplines, whether we talk of UAVs or you talk of strategic electronics or you talk of ammunition or whatever. So this is what we do in the sector. And I just thought I'll take a pause here and then we can come back.
Thanks, Panel Kavan. It was wonderful. Vishwajit, your views on components of smart factory in aerospace lean manufacturing. How companies should adopt the smaller ones if they are looking at smart factory and lean manufacturing.
Yeah, thanks for the question. I'll address the second part first. But before that, in fact, Himanshu gave a very practical view of how to really go ahead in the smart factory journey. And I once again will stress on the word journey. This is not a one-day phenomenon. It's something which has to be kind of done stage by stage. See now, why it's actually important for this particular sector. See, if you look at the aerospace manufacturing as a sector, one thing which is really important for this particular any company which operates in this particular sector is precision and compliance. These are two non-negotiable aspect in aerospace manufacturing, right? I mean, because a single defect can really jeopardize the whole fleet or compromise the safety. So from that standpoint, the operational excellence is something which is really kind of critical for this industry. Okay, now let me talk about few other aspects before I get into the how to really go into this journey. So, I mean, as I started off saying that precision and repeatability is something which is non-negotiable. The other thing which are also important for an organization is speed and scalability. Okay, that's something which is needed. It's a vast market. I think Karnel also talked about the way the market is really opened up and kind of growing. And for us, we are also looking at a kind of a global, a significant pie in the global market in this particular segment. Again, various schemes of government is also focused on that. So again, an automotive system can really help scale up really fast.
Correct.
Third thing, as we do that, how do we ensure that safety and the ergonomics in our factories are really kind of maintained? Okay, because again, these are at times these are heavy engineering. So how do we reduce the human exposure into the hazardous task or very heavy task from that standpoint? That's the third aspect what I'll be talking about. And the third essentially the important the fourth important point for me is the decision making process. Okay, and that and the way I talked about, I mean, there is a whole volatile world in front of us, whether it's a supply chain or the demand side of it or the other geopolitical issues what's happening. So from that standpoint, our decision making, which we often need to do it constantly, needs to be a lot more data driven. So how do we really ensure that the systems which are generating the data and being fed to us as an insight to help us to take the right decision at the right point of time, and that will help us to get into the whole seamless digital workflow. Okay, so that's the journey. What I'm talking about is probably the end state in Himanshu's journey is something what we'll be looking at now. As we get into this journey, I mean, especially once you talk to various MSME operators in this particular space, what we hear essentially is that there is a high capital investment which is required if you want to get into a smart factory journey. Now, my answer to that essentially is basically it needs to be, and that's precisely what Himanshu also talked about, is it needs to be phased and needs to be ROI driven approach. Okay, it's you need to you can't conquer the Rome in a day. Okay, so we need to start small with maybe high impact, what we call high impact use cases, and then grow and scale fast. But while you do that, be very clear about the ROI, what we're going to get with those delta addition, what you're going to do in that journey. Now, the good news essentially is that today we also have a lot of as a service model. Okay. And if you look at, if you look at from a digital standpoint, MES as a service, AI as a service, these all are there. So that it actually helps you to avoid a lot of upfront cost. And last but not the least, there are many government initiatives which are there under PLI or the different offset programs. And as an organization, all of us, I'm sure, will be looking at that aspect of it, how to get the benefit out of it, essentially. Most of the organizations are probably as I say, it's a brownfield journey towards a smart factory. In that sense, they already have a manufacturing plant, which let's call it a legacy plant. And then how do you, in a phased approach, how do you really get into so it needs to be modular. And from that standpoint, the digital technologies do help in terms of the various middlewares or the APIs or the hybrid cloud architecture. We can get into those details at a later point of time. Now, while you get into this this journey, there are other issues. What you have in a typically a legacy environment is what I call it data silos. Okay, because we will be having, even definitely right now, each and every organization will have a huge amount of data, but they are not connected. They are in silos. Now, how do you kind of create a unified data fabric? And that's something which will, where the data flows between one operation to another operation very seamlessly. And that's something which is going to help us to move into the journey of data-driven decision. Last but not the least, while you get into this journey of a smart factory, what it means essentially is that the cyber physical system is open to the risk of cyber frauds. So that's something which is what we will call is a zero trust architecture is something what we should be looking at. And I briefly talked about the hybrid architecture. So hybrid architecture helps organization to get into that journey. So in terms of how do you secure the data of your organization to remain risk-free from that standpoint. So these are the aspects what an organization needs to keep in mind, or the leaders needs to keep in mind as you move into the journey of smart factory and lean manufacturing.
Vishwajit, and my team has sent a cybersecurity question, which I will be asking, in the second round. Poli, how can advanced metrology and inline inspection system enhance lean production in aerospace?
No, thank you for the question, Dinesh. And the topic is pretty interesting to us. Also because got to have understood that the main centrality of the topic is represented by the handling of the data, no? So, handling of the data, that means that there are several, let's say, manufacturing step. Definitely, we're talking about production step in which the data should and could be controlled, handled, and monitored, no? So, for the experience that we have, from the experience that we are using up to now, the handling of the data could be, let's say, implemented in three different steps. The one is represented by the handling at the time of the supply chain. So if I have a robust and solid supply chains, I would be requested to detect and inspect the goodness of the components that are entering into my manufacturing, in which I need to better verify the goodness and in some cases the metrological aspects. Another step that is a main one, is represented by the process monitoring that I could in some cases detect for the 100% of the processes, and in which I could propose, let's say, verify the data with the process monitoring of some tool that is performing an activities, an action, or additionally to the goodness, related to the goodness of one specific component that during the manufacturing will be controlled 100% of the time. The third, the last remaining step is aim to check the goodness of the data, is represented to the end-of-line control, in which I could perform also statistical data. So main centrality of the data is again mandatory. But in this specific step, I could better understand and the behavior of the data and statistically, and I could in some cases perform a new decision and later on some action depending of the data that I have requested and I have controlled at the end of the end of line processes. Marposs in this scenario could represent and could let's say provide a solution that could let's say cover all of these manufacturing steps. How? Specifically with components that could in some case keep the incoming order inspection, so aim to verify the supply chains. We have let's say offline solution that could equip and verify the inspection methodology. But we have also modules, monitoring solution. We have also a solution that could keep live the 100% of the work processes. In this case, we could save time. The goodness of the components that is under manufacturing is 100% controlled. And we have also solution connected to the software and to the statistical overview that could keep the end of line decision making that must be done at the end of the processes. In this case, we have solid, let's say, tools, statistical and software ones that could, let's say, resume the behavior and the control of the manufacturing that is under processing.
Poli. And ladies and gentlemen, Laghu Udyog Bharati will be hosting India Manufacturing Show from 6th to 8th of November in Bangalore International Exhibition Center. It's powered by Ministry of Defense, Ministry of Steel, and Ministry of Heavy Industries. We look forward to have you, see in Hall 1 and 2 at Bangalore International Exhibition Center. Thank you. And now, Himanshu, you wanted to share something with the
Yes.
audience.
Thank you
I
very
hope
much.
your stuff is
Yeah,
activated.
it's activated. I hope everyone can see my screen now.
Yes.
So, okay, so I won't go into what Jendamark does, and I think that's fine. We can all find that out later. Yeah, so I wanted to actually talk about a traditional factory setup and what I call as a layer zero of manufacturing. And that's typically assemblies, jigs, fixtures, trusses, ladders, assembly tools, jib brains, tackles. That's the manufacturing layer, right? And what I wanted to add upon is we need to start by starting the journey of converting a traditional factory into a smart factory, not by directly putting digital layer, but first putting a automation or a what I call a sensor layer. Put in HMIs, sensors, tightening tools, visions, AMRs, gauging systems like colleague from Marposs also mentioned. So that's the automation layer, which is essential so that we are able to collect and fetch the right data from the manufacturing layer or from the shop floor, right? And optimize the shop floor first, followed by the layer of automation. We bring in the layer of what we call as an operating system, which is worker guidance, part genealogy tracking, process security, quality assurance, and the smart analysis in the end. So it's important that we understand that we can't skip a layer directly. Yes, you can have some parallel implementations, but these are layers on which the foundation of manufacturing needs to be built upon, right? So you start manufacturing, automation layer, line operating system, and then comes the ERP layer. Now, what I have come across in most cases is there is a manufacturing layer and then there is directly a ERP layer. And the middle two layers, the automation, the sensor layer, to fetch the data, to improve the productivity, to improve the systems, like a simple thing like a tightening. Typically, unfortunately, we have seen few aerospace companies where they are still using a wrench to tighten. A torque of 250 Newton meters, there's a guy with a wrench tightening it and clicking it. That's nothing wrong in it. Yes, I agree that the torque is still safe and secure. But when you ask the next question, when was the torque calibrated last time? Is the torque correct, checked, documented? Is really the angle given correct? So these are all judgmental things. But that's the first step to be implemented to improve the production or the manufacturing layer. Based on that, then you bring in the operating systems, which are then ensuring that the right parts are picked and fit, and ensuring process sequence is followed. And this data then comes into the ERP or the SAP systems. And that's typically when you can think of the smart factory solutions. So that's what we are trying to achieve. And like I mentioned before in our initial dialogue, Dinesh, that the problem statements in automotive and aerospace, and I always go to the reference of automotive because I think a lot of times people in aerospace industry tell us that, oh no, our problems are different. Now, that's why I put down certain key problems: complex and time consuming assembly process, lack of flexibility in manufacturing systems, integration of advanced technologies, regulatory compliance and quality control, supply chain management and parts availability, skilled labor shortage, high manufacturing cost, sustainability and environmental impact, which is kind of, let's say, not thought of right now in aerospace a lot, at least, and it's a lot of buzzword right now in automotive. Long cycle times, delays in production, and integration of new aircraft or new technologies. Now these are problem statements which are actually common on both sides. So yes, there could be differences, and I'm not denying that there are differences between aerospace and automotive. But if you look at the commonality, these are the common problems which even automotive industry faces, which automotive industry has navigated and solved already. And I would like to give some examples of that. You know, when you look at, and that's how the solution is. For example, correct part assembly. Are we assembling the correct parts for the right product being made, or right parent part being made? Here, a simple scanning system, like I mentioned, I always have to scan. Let's scan parts. Let's scan barcodes, use our phones. It is applicable for aerospace. BOM and variant management to know which process to follow. Quality control and defects to know, instead of only having an inspector checking, to observe, understand, and use systems to demonstrate what you're doing is right or wrong. Using simple bolting tools which collect the right torque data. Using sequence control, right? Instead of telling the operator, please follow the cross bolting, we have already implemented solutions in automation industry which follow AI vision systems which are guiding the operator and ensuring he follows the right sequence of tightening. Using dynamic quality checklist to record the data instead of having paper tick marks. Take a smart tab, take images, put comments. Subsequently, skilled operator, like we spoke about lack of skilling, using VR. VR is extensively used in automotive right now for training the operators before they get qualified to go on the line. Same process of training in VR is applicable in aerospace. Even pick to light racks. And we've got so many factories now which are using pick to light mechanisms where you indicate the operator which part to pick, the right part to be picked. Same racks are there in aerospace, but there are no pick to light indicators. Record of building parts. What you're building gets documented automatically, and you don't have to every time open a big fat book to see the sequence of operations, because it is seen to you visually on a clear screen with visual guidance in local language. So even if the operator, we spoke about something coming up in Bangalore, even if the operator comes from Uttar Pradesh, he should be able to see and understand without knowledge of English what he has to do in his local language. Once all this data is available, we have all the data, because now the data is digital, you can collect all this data in your system and use any analytical software solutions which give you analysis to tell you where is your bottleneck, which product took more than estimated MTM analysis, where are you losing time, how it can be improved already. And there are so many software solutions available which use the data to make this analysis and offer you solutions to improve your own efficiency. Last but not least is the digital documents. And we spoke about compliance, and we work in aerospace industry extensively. And we are also surprised when we are every time when we export an aerospace component to European markets or to Indian OEMs, we have to send a component, but with a big notebook of things which have to be signed, verified, stamped. And that's something which you look at where we are today in our what you call digital age, but to every time have people signing documents, filling in forms. We can all move to this simple barcoding solution, simple digital solutions where you can digitally sign. I mean, the banking sector has moved significantly to the digital solutions where we are now signing deals digitally, putting digital signatures. But in aerospace, we are still supposed to go around signing papers and ticking marks. The same compliance, it is legally accepted to go digital as well. So you don't have any dearth in legal, or there's not a dilution of legal authority or legal sanctity. It is the same documents done digitally. The advantage is it's easily accessible. Imagine something now gets transported from us in India to Poland or to Hungary, where we have got aerospace manufacturing companies working. There we have to send these physical copies as well. So that's something which I see that we have already solutions implemented in automotive industry, which are easily, immediately seen in automotive, which can be put in aerospace industry as well. These are some examples which I just thought about. Again, the question always is, where do I start with? And we always come with this complex solution, but like I said, let us start with something more fundamental. And this is one example which how you can start. If anybody makes, I have taken an example of a Rolls-Royce engine or any engine, some take names, but any aerospace engine. What you can see is the way the assembly is done. You can actually implement already an AMR which is moving the heavy engine around instead of having shackles and big EOT cranes moving parts around. You can always start with the yellows are the vision cameras which are monitoring what work is being done. Right? We have got operator guidance system which tells the operator what are the next tasks to perform and records the time to do the operations. Tooling racks and mountings are already there, which are again with pick to light solutions. We have HMI arms which show the operator the next process steps. AMRs with collaborative robots, and these are all solutions which are implemented almost more than a decade back in automotive industry, where we can easily see that manipulators for talking, manipulators, and I think, but Mr. Bhattacharya mentioned about ergonomics. Ergonomics is one of the most important things when it comes to automotive, and in fact, in aerospace, it's even more important because we are lifting slightly more heavier parts, right? So I try to just give you a short video of how it's done in automotive. Here's a worker guidance screen, shows the operator what is to be done. He picks up the right sockets. Automatically, the right tool gets selected. So he doesn't go and select the right tools or pick the right wrench. Tools are working now. He goes, puts in the right socket. The system is monitoring where he's going. When he's going to the right location, he tightens the bolts and the torque is always okay. So you don't need a verification system. The data now, if you see, gets recorded automatically. So there is a record of what torque was applied, when it was applied. If it is not okay, it becomes red. So you don't move around or you can't move ahead with a not okay torque. So this is something which we realized is implemented since many, many decades now. Another solution is, okay, if you have multiple tightenings which have to be done at the same time, you can use automatic bolting solutions like in wheel bolting. For automatic bolting, improves efficiency, productivity immediately while ensuring process quality already. So these are simple tightening examples for sequence control, automation, which are immediately applicable in aerospace industry. Also, when I spoke about AMR with collaborative robots, they've got AMRs with mounted with robots mounted on them, which go around, in this case, an engine. This is in our factory. We did a demo setup for a customer, which goes around and checks everything around the engine. And same thing we have done for a fuselage. Right now, you can go around the fuselage, go around checking, so that you are now not relying on an operator to do that job and verifying everything. Digital records available for the future for analysis immediately. Scanning of parts immediately available. When you scan a part, it tells you the process to be followed, monitored, sequences ensured, so you don't miss out any parts. Even like pressing operations, these are with pressure, force, and distance control. picking the right parts. So, simple things to ensure that the operators who may or may not have the skills are also able to work. This also solves our problem when it comes to low skill or illiteracy or creating more jobs. And that is something which we felt that an operator assistance worker guidance system, which is already available, you don't have to use Vuzex glasses, or you don't use glasses required. You can start with normal systems, picking the right tools, tightening the right locations. Already I mentioned about sequence control in tightening solutions. So these are all systems which are integrated into one solution so that you can access the data in one location itself, and you don't have to look at what we heard about data silos. All systems, all data come in one location. Easy analysis are available for the future improvement in efficiency and productivity. So yeah, I think I would not come to the part, but I think that's something what we, like I said, we are into manufacturing of aerospace for jigs, fixtures, trestles, ladders. We have our solutions for implementing automation layer. We have Odin, which is our software solution, which I showed you about, ensuring process security, worker guidance. And for ERP, we have partnered with Tech Mahindra to implement a whole smart factory for the ERP layer. So that's something which I wanted to just share with the team, that something what we have been doing, having seen both sides of the factory or businesses. I think this is something which will interest everybody, and it is not difficult. It's an easy starting step to reach the smart factory. Important is to take the first step, scan a barcode, and then I think everything falls in place or starts falling in place.
Thanks, Himanshu. Save paper, save planet. I will,
Yes.
I will say. And, so, Colonel Kuber, from a defense procurement standpoint, how critical is manufacturing agility enabled by smart factories?
So you see, I mean, I don't know whether I want to call it as a Western concept, or I want to call it as as a a new impediment to growth. But I think between smart and lean, they both are necessary. So it has almost become it almost become mandatory, as I see it, that factories should implement smart manufacturing. Um, Lean, of course, because we are still a growing economy. We may be the third largest economy of the world, but per capita wise, we are still out there. So I think we need to adopt both smart and lean. Now, there are some fundamental issues when it comes to the defense sector. So the defense sector is plagued with legacy systems and legacy industries. So you see, when we started our journey into defense, all this was not heard of. So it was only the man who used to, align the gun with the barrel, and align the barrel, and also even make those grooves inside. And it was more of a human effort oriented workplace. Companies like Hindustan Aeronautics have already adopted some sort of a smart manufacturing and tried to integrate things like digital twins and AR VR integration and all that. Now, when I see anything, between Hindustan Aeronautics, between HAL and say Boeing or Lockheed or Embraer, I think it's a fair comparison with Embraer, because both HAL and Embraer are probably at the same level. And also there is a lot of cooperation going on. So now, precision is sort of mandatory. I think there is no choice in terms of not having precision, because today we are talking about when you fire a round and the round goes about 40-50 kilometers away, there was a circular error probability of about 500-800 meters. Today we are already talking in terms of 10 meters. And the companies have collaborated with academia. And when you see IIT Madras has already joined hands with Munition India towards implementing this type of a circular error probability, which really means that today we are sort of adopting those standards that Mr. Himanshu was bringing about, because I thought he was making some very, very great relevant points out there. Our problem is, we need to implement this from the raw material stage. Raw material probably is the most critical of all the elements of manufacturing, because if we do not choose the raw material right, and if we have not introduced AI and other sort of
Technologies.
AI, other technologies, to be able to choose the raw material correctly, and then your whole manufacturing process can be the best, but it will not stand the test of time. So I think at that stage, if we can sort of even have, first let us go with the digital twin, and test everything on the twin. You save a lot of money. Number one. Second is, today the armed forces are already thinking in terms of carrying out trials on digital twins. So earlier, if anybody made a gun or anybody made an aircraft or whatever, it goes for trials from number of places. Like typically, how do we conduct an aircraft trial is the aircraft takes off from Leh or Ladakh at -40 and lands in Rajasthan at +50 and undergoes the complete vagaries of temperature, pressure, and everything en route. And therefore, if it can withstand all this, then we say, okay, it seems to be all right. And when it comes to other systems like, strategic electronics, like radars or others, so we test them in various places. We test them in plains, we test them in riverine terrain, we test them in mountains, we test them in jungles. So because we've got all possible terrain in India. So from -40 to +50, we've got everything. And so today we are thinking in terms of using digital twins. And can we do the trials? At least most of the trials we do it here so that we save cost. Imagine the equipment going from place A to place B and doing all that. Third is, like Mr. Himanshu was bringing about documentation. I think documentation is very, very important, especially in warfare. Like for example, there was an event. There was an Indian system or an Indian munition that was found in the war zone. So how do you say that it is Indian? And which side did you supply it to Russia or to Ukraine? How did it find itself over there? So the concept of documentation, the concept of standardization, the concept of coding. So we are going into so many other things, like we have adopted the NATO standards in coding, and we have also adopted a lot of these technologies like robotics. So I mean, I was amazed to see dark factories. So when we talked about dark factories, and when we heard about dark factories, everybody ridiculed China for doing that. But today, you see, dark factories, the moment you have a dark factory, what it really means is that you're saving a whole lot of electricity. You're saving, you're actually creating a greener sort of an environment out there, because these robots will keep one is they keep working all the time, and second is they keep working in the dark, and so there is a lot of this thing. So today there are two things when it comes to military aerospace, military aviation, military aircrafts, and defense systems. One is the capability and the second is capacities. So when there is a warlike scenario, what you really need is surge capacities. At that time, can you produce them in numbers? And that can happen only if you have adopted smart manufacturing. You see, if you're going by the traditional methods, you will take a lot of time. And smart methods, what really happens is just repeatability. You put it there, and The idea of all these things is what? The moment you adopt these standards, what really happens is repeatability becomes sort of assured, and it's like AI. It can keep doing the same thing again and again without making any changes in the process or precision or that. So therefore, I think that way I would rather believe that it should be made mandatory. Now the question comes is, what are the economics of an established factory adopting smart manufacturing? So I think that is where we need to probably again draw a line and say maybe the large integrators can do it, and let us not penalize our small, our MSMEs who are as it is doing a great job, and all that they have to do is, when they do those particular subsystems and components. I think I have not. I'm yet to come across an MSME which is not doing a good job. I think they're doing a very, very great job. So then where the problem lies? The problem lies in the supply chain. So, for example, if I would consider Bharat Electronics or HAL or Tata's or L&T or Adani's or whoever, if they have to monitor the supply chain, then what? So they have to make it really smart. So from the raw material, where the raw material is getting sourced, as defined by the OEM, to the selection of that, to the processing of that, to the components, subsystems, systems, and when it comes to integration, so now the entire supply chain is getting monitored, and that can happen only if you have implemented smart manufacturing. I do not know if that is the best thing to do, because on one side it seems to be very interesting and very smart. Oh, you can monitor the entire supply chain, but one of the greatest fears in implementation of smart manufacturing is a cyber attack. So can I make your factories redundant at the time of reckoning? I mean, this is a question that we need to answer. Can we? I mean, you don't need to put any physical ammunition anywhere. You just need to do a small cyber attack, and the entire supply chain of HAL or BL or whoever, Lockheed Martin or Boeing, will collapse. Now, companies like Boeing and all have implemented so much of all this. I mean, we hear that they have done this and they've done that, and the number of crashes that are taking place. I always wonder, will it ever fall on my head? I mean, I don't even know. In spite of all these smart manufacturing, still there are issues. And therefore, I think we need to draw a balance when we talk of all this, and that is a very delicate balance that we need to draw about and say, okay, this is how we should do it. Yeah. Thank you.
Thank you, sir. So Vishwajit, now let's come to you. So my question is two-part. What digital transformation framework does IBM recommend for aerospace companies? The second question is, to take it from, Colonel Kuber, that how do you ensure cyber security and data integrity in highly connected aerospace environment?
Okay, let me take your second question first. I guess that will be a kind of continuation, because that's where Cornell ended with a concern. See, I mean, the fact is, as we embrace digital technology, our factories becoming smarter, more connected, and autonomous. But at the same time, this transformation comes with this new threat. Okay, so and let me start with the simple truth. Okay, every connected device, whether it's a factory or a machine, is a potential entry point for a cyber attack. Right. So this, in a smart factory where operational technology, what we call OT, and the information technology, which is the IT, that convergence actually happens, the stakes are even higher. Okay, a single breach can halt production, compromise intellectual property, and even endanger human safety. I'm not getting into the war zone area, but even at a business context, that's anything is possible. And just to kind of collaborate with few numbers, there's a trust wave risk radar report which kind of came out for 2025. Said 80%, 87% or 87% of the cyber attacks in the manufacturing sector were originated from phishing. Okay, and it's a clear sign of human error as a clear vulnerability. So it's and so at the same time, ransomware continues to be the most disruptive threat. Okay, some more data point I'll share. I mean, this is across industry or across manufacturing segment. 79% of the cyber detection in last year were malware free. There's a 442% increase in phishing attack in H2 2024. And there is a 4,000% surge in phishing attack, interestingly, since the release of ChatGPT. I don't know whether it's a core. I mean, that's what the reporter actually talks about. And frankly, in India, we had seen in the last couple of years, we had seen multiple such issues. Again, and I'm talking across sector. Large telecom major over here had a 278 GB of user data leaked. That happened in June 24. Local electronic consumable company, there are 7.5 million customer record exposure that happened in April 24. A financial service organization, a ransom where attack actually jeopardized their complete operation. It happened in February earlier this year. Globally, and these are local data I talked about, and similar thing you will be talking about, seeing it in from a global standpoint. From an aerospace defense perspective, UK Ministry of Defense has a personal data breach happened earlier this year. Okay, CrowdStrike, Microsoft made newspaper headline in across. Expose the whole vulnerability in our supply chain from that standpoint. And to be very frank, when you talk about this phishing attack, maybe all of us over here have seen those emails and the phone calls throughout. So these are all there, and something which is which we need to kind of ensure that we deal with that. Now, from a smart factory standpoint, what it really means. So it means that building resilience into every fabric of our digital infrastructure. So at every layer of our operation, we need to really look at it from a cybersecurity standpoint. So it's not just about just the firewall or the antivirus software running in our machines or in our laptops. It's about the architecture, what we are going to follow. And I talked about a zero trust architecture. What it means that no device, I mean, as a security expert, I mean, one will say that I don't trust any device or any user by default unless it is verified. That's what it is, the ethos of a zero trust architecture. And that's something which needs to be kind of followed all across. Real-time threat detection, and that's where really AI comes handy. And these technologies are pretty much available across, where we're able to monitor the anomalies in the machine behavior or the network traffic, and able to kind of create those notification to the right authorities so that immediately the action can be taken. And once we get that, we should be able to isolate those critical systems from that breach so that it doesn't cascade further. And this is a very key component of the architecture what we are looking at. Breach may happen, but how do I kind of create the resilience around it? Okay, so from that standpoint, if a component or if a user is is kind of compromised from a security standpoint, how quickly I'm able to isolate it from the larger network so that I am not getting exposed further.
Himanshu, you wanted to ask something?
No, I just wanted to, no, sorry, I don't know if we should just finished. I would allow him to finish first, of course.
Okay,
I just
okay.
wanted to add a comment on that.
Please go on.
So,
Okay.
you know, I get this question asked by many companies, automotive, that if we are exposing our data outside to the world and there's going to be cyber attack and we'll stop production. I have a practical solution, but before the practical solution, I think it's important I ask the same question to them that, so we always have, I think, hundreds of accidents daily happening in India, anywhere of the world, right? There are car accidents, automotive accidents happening on the road every day. That doesn't mean you stop driving cars. Which that's the first fundamental thought, that no, because cars will have accidents doesn't mean you stop driving cars. You make better rules, you follow the rules, and you make cars safer. That's the approach which should be implemented than saying, okay, cars have accidents, so let's not drive cars. Because there are certain things in life which you can't control. Like Colonel also correctly mentioned, that you can't control everything. There's going to be a cyber attack somewhere. There is going to be a threat sometime. You can't control what, like you rightly said, what Pakistan thinks or what China thinks and does. We can't control that. What we can only do is control what we can do is getting prepared better. So whenever anybody is asking me always that there's going to be, we can't implement smart factory solutions and digital solutions because there will be a cyber attack. The worst thing to do is remain in that age where you're not exposed to digital technology and think that let me put a wall around myself and remain in my cocoon because there might be a cyber attack. That's the whole analogy which I want to just give, that no, you can't stop driving cars because you're not going to have accidents. You have to prepare yourself for things which you can't control and not worry about, prepare yourself for things which you can control and don't worry about things which you can't control. Yes, there's going to be a cyber attack probably. How can you defend yourself better is the right way, rather than thinking let's keep the wrenches and let's not go to cloud. So that's just wanted to add that analogy.
I mean, thanks, Himanshu. So yeah, I mean, basically, see, the smart factories is a marvel of modern engineering. Let me kind of say that, and that's something. But it must also be in a fortress. Okay, that's the analogy what I can kind of give it over here. It's you're building factory for future, but at the same time we need to ensure that they are smart and efficient, but at the same time they are secure by design.
Right.
Now that's the concept in itself. What it really means essentially is that while we get into the journey of smart factory or building into that or getting into that journey, we need to involve the cybersecurity expert right at the design phase of the first smart factory system. Collaborate across the department, IT, the leadership, and needs to be aligned with the risk management.
Okay. And is there any way for cybersecurity audit, Vishwajit?
I'm coming to that.
Sorry.
Yes, there are two things. There has to be a continuous training, because as I was talking about, the phishing attack is not an architectural failure, but it is a human failure. Okay, traditionally, and that's 87% of the data shows that it actually happens because of that. So there is a need for a continuous training. There is a need for audit, and there is a need for simulation exercises to prepare for cyber incidents. As Cornell said, as Himanshu also said, cyber incident may happen, but we need to make our organization resilient enough, and let me stress on that, to bounce back from that incident and bounce back quickly. That's where I'll kind of end that particular topic over here. Coming back to your first question, Dinesh, in terms of how to get into the. So there are three things what we always look at. One is, I mean, it's a journey, as we said, and the journey has three actors. A, the process. What are the processes what we are looking at from a smart factory standpoint? I mean, whether it's a just-in-time from a supply chain standpoint, or a continuous improvement framework, what we call Kaizen very popular in automotive industry, thanks to a lot of those Japanese companies in that particular segment. Six Sigma, focus on quality and the variation control. SOPs for reduce the variability and the standardization, which some of us spoke about. And lastly, sustainability is no longer a buzzword. Okay, this has a very clear business impact and helps also the control in emission also helps us to save money. So these are the these are the few of the process part of it, which we need to ensure that we adapt the right processes. We have the technologies to support that. Go digital is the theme very clearly what we will say. Now combine the traditional lean tools, what I talked about, with the digital technologies. IoT for real-time process monitoring, AI for predictive quality, root cause analytics, digital value stream mapping for, let's say, visibility and optimization. So that's where the technology really kind of come in. And lastly, the people. See, that's probably the most important aspect over here, because skill will enable work in a small factory. Cross-functional collaboration, breaking the silos, that needs to happen along with that. And probably as I speak to the leaders across manufacturing organization, this is where most of the organization are finding challenges, and also the leaders in segments, including aerospace defense, are really investing on that. So looking ahead, it's a convergence of AI, sustainability, and workforce transformation that's going to define the next decade of aerospace manufacturing in India. That's where I'll end, Dinesh.
Thanks, Vishwajit. Ladies and gentlemen, do drop your questions. I will try to take as many, because time flies, because I have got distinguished speakers, and for me myself is a lot of learning. So Poli, can you give us any example where Marposs solutions have helped our aerospace customer? Because since you are visiting customer across Europe, you will soon be coming to India. So can you share any case study where your solution have helped?
Yeah. If I'm allowed, Dinesh, to share some slides, I will be happy to share some content, because jumping back to the different situation in which Marposs could propose a solution, just to resume which are the different needs and the different step where Marposs up to now is proposing a solution. If we are resuming in the slide that we are seeing the possible manufacturing step, we could clearly see that there are several manufacturing step upwards in which Marposs could propose a inspection solution. So we could provide solution for the incoming order area. We have also dedicated and specific solution processes that could equip the machine tool setup. We could also provide a solution for the machining. So we have solutions specifically for the machine and the part monitoring solution that help to prevent any kind of collision, that can help for what concerns the predictive maintenance. So we can provide solution that control 100% of the processes while the manufacturing is happening. We have also, as we were saying before, some specific solution that could keep the end-of-line check through statistically process controls. So in this case, we could resume several data that could help the director or the quality engineers that need to perform some action later on this let's say flow of processes. Jumping back to which are some physically and some easy example in which Marposs could provide a solution. We have a specific solution that could equip several parts of the components that are part of the aerospace manufacturing. So we could equip both the structures and the engines, let's say macro words, And specifically, there are several components, as the one that you are seeing right now, in which Marposs could provide specific solution. As we can see, we can inspect the part of the structures, as instance the fuselage together with the airplane windows, together with the wheels, and specifically we have solutions for the let's say part of the engines that are needed as gear, shaft, injector, and fuel cases. The different processes and the products that we have for all of these, let's say, sample components are pretty various. Are various because we have a long history of knowledge stated in the automotive industry that had helped us in the past to build a various list of proposals for what concern both the on machining process solution. When I'm talking about on machining, Dinesh, I'm talking about both of the part machining and also the production processes. But we have also a long history of solution that could keep all of the offline classification check. A solution that, I say, are various and are belonging to some dimensional check together with functional check too. We could provide solution, contact solution, but also we have developed specifically non-contact solution and also optical ones provided. We are in condition to provide solutions specifically also for the leak testing in both air and helium solution, and also gauges that could perform various and statistical analysis. So depending of the type of manufacturing that you are in, specifically for the aerospace component, and depending on the processes that you want to keep, so as saying, incoming order inspection together with machine tool solution, machine tool area where you need to keep 100% of the life of the processes, and checks, Marposs has different product and say solution that could in some cases help to provide metrological inspection, air inspection, dimensional functional inspection. So we have a various list of product solution that could keep different part of the aerospace and defense manufacturing.
Thanks, Poli. So I have got list of questions and time is very less, so I want to utilize it in a very effective manner. There are three questions are posted. I will, it's by Adar Siddharth. In today's data-driven industry, data ownership and access are critical for every company. What are your thoughts on recent case involving Microsoft allegedly preventing Naira from accessing their own paid for data? What implication does this have for the broader industry, and what step can be taken to mitigate such risk? Vishwajit, I don't know how.
I think I'll put it in a simple word. See, we need to ensure that the design what we get in, and as IBM, what we believe the future is very clearly is hybrid by design. Okay, it's hybrid cloud is a kind of is an approach which each and every organization needs to kind of look at it. While we get into the journey from an Indian context, we also need to understand the various acts like DPDP is coming in. From that standpoint, the architecture needs to be aligned to ensure that we are within that ambit of the law, and able to do our business profitably and efficiently from that standpoint. That's a very short answer what we need to kind of for me from my to address the scenarios which are evolving from that.
Himanshu, you want to add?
Sorry, no, I'm fine with that. I think it's
Okay,
absolutely fine.
so
No,
My second
this is
question is
a
more interesting.
this is a case of total dadagiri. It had got nothing to do with either a attack or something, and that is where Atmanirbharta really kicks in. You know, Mr. Trump can change his words every moment, and if I would guess in 24 hours how many statements he would make, I think he can make 24,000 different statements, and that is the capability of a person who can do anything. And here, I mean, they had to the moment Nyara went to court. I think they quickly revoked their thing and they fell in line. I think somewhere we have to come down heavily with a hammer on some of these companies, and I think it should work. And I think India today, in the geopolitical context, has started flexing its muscles. It is not the India of the yesteryears where you could, pass it off. And even yesterday's statement by Mr. Trump is, I think, very disgusting when he talked about India and Russia and they can do what they want to do with each other. I mean, it's a pretty disgusting sort of a statement, and I think we will come very strongly with that. So
and we have
it's
a
not,
question.
yeah.
We have a question from Pradeep Kuar. Why are A&D startups getting such low or nil support from the industry and the ministry compared to other startup and other industries like F&B? We A&D startup are denied vendor registration in CPSU, GEM in platform for big players rather than startups. Denied unit setup as there is a huge. I want.
Okay.
So I will take this question. Lastly, I want to a conclusive
I think
statement. I want to,
there was a good question. The second question, if I could see that,
okay,
right? There was
please,
on.
please take
So
it.
if I could see that, what is the biggest
Yeah, yeah, please.
challenge? I think the biggest challenge most companies have faced and will continue to face in smart factory implementation is a cultural challenge.
Okay.
I think for me, cultural transformation comes before digital transformation. We have become a digital economy thanks to us adopting in our social life to scanning barcodes and paying money and not worrying about whether actually the money is going where. We just like, yeah, money is transformed, money is transaction. I think culturally we are now used to that. To an extent now we don't carry our wallets, right? And
Yes.
that is reality of 5 years back, where we were always worried about how much cash we are carrying, to now not even worrying about carrying our wallets, because we know anywhere you go, even if it's a remote village, you will have your phone and you will scan a barcode and pay money, right? And
Yes.
that's the cultural transformation which has happened, which is allowing us to take the right digital steps for the future, or becoming, like we said, paper free and all of those things. So I
Right.
think culturally to accept that whatever we are doing in our social life, and somehow there's a stigma in industry and more in aerospace industry, because aerospace somehow for me also, in my former years of automotive world, uh, aerospace was like a guarded fence. Nobody
Yeah.
could know what is happening in aerospace, or you can't know, you can't. Obviously it was a public, it was not private, it was only privately held but not open to public. But somehow this black box of aerospace manufacturing needs to be opened up, and all the things which we do in our social life, using all the digital solutions which we are using in our social life, whether it is paying, whether it is e-commerce, there are so many things which we easily adopt in our social life, which means the employees working, the people working in aerospace industry are actually using this in their social life. They just need to allow those, some of those solutions to be implemented in the aerospace manufacturing. And it's not complicated, it's just what you're doing here, allow there. And like I always say, start by scanning a barcode. Scan a barcode, read your vision mission statements of your company on a barcode. That's your first step, and then everything else starts falling in place one by one, because vision is there, mission is there. But to translate that to a digital level, if you're still putting printouts on your factory shop floor, that's not digitalization then.
Ladies and gentlemen, the discussion is just getting started, but since there is a tab, I will be hosting someday, where there will be no tab, we will go for, on and on. I will be needing a closing remarks from everyone. Before that, I'm just sharing a data. I just, which I came across. Industrial robot uses by country per 10,000, employee. So the South Korea uses 1,012 robots. Singapore uses 730. Japan uses 397, Germany 415, China 322, and India 5 to 6 robots per 10,000 employee. So keeping this thought in mind, what will you say to SME, MSME who want to adopt this technology, whether it's lean, whether it's smart, whether it's a small software, any digital change they want? Closing remarks from everyone, keeping SME and MSME into mind. We will start with you, Himanshu.
Oh, although I'm an automation company, I'm not a fan of robots, especially in the Indian sector, to be very honest, because I think our strength is our population. And if we are going to use robots to do things which a human can do, then we are undermining our own strength. I think more than automation, digitization to use and generate employment to make our unskilled employee operators and unskilled population employable, that is more important, more effective than buying robots from outside India. That's my honest take. And like I said, we can build automation solutions, but you don't need to buy robots for that. You can buy with digital solutions a lot more effective things. And yeah, my closing statement is still the same: scan the barcode.
Vishwajit?
Okay, well, the India is a digital economy, is growing very fast. It's supposed to reach 1 trillion by end of this year. Okay, so from that standpoint, the manufacturing industry and specifically the aerospace industry also needs to get onto this journey. But having said that, my advice is very clearly start small and scale fast.
It's a great message. Colonel Kuber, your message,
Yeah,
closing remarks.
my message is very simple because I've been associated with a lot of MSMEs, and I know where the shoe pinches for them. Just to give them orders or hook them, you adopt manufacturing is not a great idea. Smart manufacturing is not a great idea. It's normally a husband and a wife show, or a mom and a child show, and they are all they stake everything. They have everything at stake. Their families, their property, everything. I mean, they are living almost hand to mouth, many of them. So I think what we should do, I think what we should do for them is more important than what they should do in automation. What we should do for them is, oftentimes I see large companies scrounging onto them and nailing them to the last rupee, and giving them very, very less margins. While I'm talking purely aerospace and defense, while they themselves enjoying very huge margins when they pick up large contracts. So I think first that mindset has to change. We have to sort of treat them like partners. That's number one. And as and when we allow them to grow, I think when an MSME grows from a micro to a small, and a small to medium, I think this transition should also be propelled by adopting smart and lean manufacturing processes. So at micro level, I think we should just leave them alone. And as they transition, and if they want to say, if an MSME wants to avail the benefits under the MSME Act, so you say, okay, if you're a small, I want you to do the following 3 things. And if you're a medium, I want you to do the following 5 things. And I think if we can sort of mandate that for availing of these benefits, I think that should sort of help a little bit. Thank you.
Thank you, Colonel Kuber. Poli, your message to
Yeah,
MSME and SME?
personally, I retain that the increasing and the growth of the people for the upcoming years will be followed by increasing of the skilled knowledge that the people are going to acquire. Quite totally agree about that.
Thank you. Thank you, Vishwajit, Himanshu, Colonel Kuber, Federico. I will keep bothering you because we are just getting started, because we will be totally doing a 13 session till November. And on behalf of Laghu Udyog Bharati Karnataka IMS Foundation, I would love to invite you to India Manufacturing Show in Bangalore, and we'll be sharing the invitation soon, and looking forward to see you in an in-person event. Thank you once again. Thank you for your time and support. Looking forward to see you soon.
Thank you very much. Thanks a lot.
Thank you very much.
Thank you.
Thank you. Thank you.